Imagine, if you will, a star. Not just any star, mind you, this was a true giant, a behemoth of the cosmos. It resided in a galaxy far, far away, a spiral galaxy designated NGC 6946. We call this galaxy the Fireworks Galaxy. It earned this name because it hosts an unusually high number of supernovae. This particular star, known to astronomers by the rather unpoetic label N6946BH1, was a luminous blue variable. Think of it as a rock star of the stellar world, prone to dramatic outbursts and shining with an incredible, fierce intensity. It was truly a beacon in the cosmic night, a point of immense energy and light. This star was massive. We estimate it was about 25 times the mass of our own sun. Consider our sun, a fairly average star, yet it contains 99.8% of all the mass in our solar system. Now, multiply that by 25. That's the kind of heavyweight champion we were observing. Its brightness was equally staggering, radiating energy at a rate millions of times greater than our modest sun. For years, astronomers kept a close eye on N6946BH1. Its sheer size and its stage in stellar evolution made it a prime candidate for a spectacular demise. Astronomers are patient observers. We watch the skies, sometimes for decades, tracking the subtle changes in distant stars. N6946BH1 was one such object of intense scrutiny. Given its immense mass, it was always destined for a dramatic end. The laws of physics, as we understand them, dictated that its core would eventually run out of fuel. When this happens in a star so massive, the core can no longer support itself against the crushing force of its own gravity. The result? A catastrophic collapse followed by a violent rebound, a Type II supernova. This is the textbook fate, the expected grand exit for stars of this caliber. The anticipation was palpable within the astronomical community. Supernovae are more than just pretty lights, they are cosmic laboratories. They allow us to test our theories of stellar evolution, nuclear physics, and even cosmology. Then something entirely unexpected happened, or rather, something didn't happen. The star, N6946BH1, which had been shining so brightly, simply vanished. Around 2015, astronomers looking at the location where this massive star should have been, found nothing. Well, not exactly nothing. Where there was once a brilliant blue point of light, there was now only a faint infrared glow. The star itself, invisible light, was gone. It didn't explode in a blaze of glory as predicted. It didn't gradually fade away over centuries. It just disappeared from optical view over a remarkably short period. This was not in the script. Imagine the scene in observatories around the world. Astronomers would have pointed their telescopes to the familiar coordinates of N6946BH1, expecting to see their old bright friend. Instead, they would have seen an empty patch of sky, or at best, a much fainter object. The initial reaction must have been one of confusion, perhaps even disbelief. Are we looking at the right spot? Is there something wrong with the telescope? These would be the first thoughts. A star 25 times the mass of our sun doesn't just switch off. It's like a mountain suddenly vanishing from the landscape overnight. When something this extraordinary happens in science, the first step is always to doubt your own observations. Could it be an error? A glitch in the instruments? Perhaps the star was obscured by a dense cloud of dust that just happened to drift in front of it. Scientists are, by nature, skeptical. So the astronomical community went into overdrive, meticulously checking and rechecking the data. Different teams using different telescopes observing at different wavelengths, all focused their attention on the patch of sky where N6946BH1 once blazed. The goal was to rule out any mundane explanations before jumping to more exotic conclusions. The evidence began to mount, and it was compelling. The Hubble Space Telescope, our eye in the sky, provided crystal-clear images. Before 2015, the star was undeniably there, a bright blue beacon. After 2015, it was gone. The Large Binocular Telescope in Arizona confirmed these findings from the ground. If it were a simple case of dust obscuration, we would expect to see a significant reddening of the light before it disappeared, and the infrared signature might have even increased as the dust absorbed and re-radiated the star's energy. While there was an infrared source, it wasn't consistent with simple, thick dust suddenly appearing and perfectly hiding the star. The data was cross-validated, the calibrations checked, and the conclusion was inescapable. N6946 BH1 had indeed performed a cosmic vanishing act. Section 5, Theory 1, the silent plunge into darkness, a direct collapse black hole. Scientists turn to profound theories to explain the star's disappearance. One leading theory is direct collapse into a black hole. The star's immense gravity causes it to collapse without a supernova. Instead, it forms a black hole directly. No explosion, just a silent plunge into infinite density. This is predicted by models for the most massive stars. A supernova requires a powerful shockwave. If the star is too massive, the shockwave might not escape. The material falls back, forming a black hole. The star is swallowed without cosmic fanfare. A quiet death for a mighty object. If N6946 BH1 underwent this, it explains the lack of a supernova. Section 6, Theory 2, the cosmic misfire, a failed supernova's whisper. Another intriguing possibility is that N6946 BH1 attempted to go supernova, but the explosion failed. This is a subtle but important distinction from a direct collapse. In a failed supernova scenario, the core collapse does initiate an explosion. A shockwave begins to propagate outwards, but it just doesn't have enough oomph. It's like a firework that fizzles instead of bursting spectacularly. The shockwave stalls within the star's outer layers, unable to overcome the immense gravity and eject the material. Most of the star's mass then falls back onto the central remnant, which would likely still become a black hole. The key difference here is that a failed supernova might not be entirely silent. While it wouldn't produce the brilliant, galaxy-outshining display of a successful supernova, it could still generate a less energetic outburst. This might involve the ejection of some material, but not the entire envelope of the star. This ejected material, or the shockwave's brief push, could explain the brightening observed in N6946 BH1 around 2009. Perhaps that was the star's final sputtering attempt at a grand explosion, a precursor to its ultimate collapse and disappearance from optical view a few years later. Section 7, Theory 3, an alien megastructure, the Dyson Sphere hypothesis. Now we venture into more speculative but undeniably fascinating territory. What if the disappearance of N6946 BH1 wasn't a natural stellar death at all? What if it was something artificial? An advanced civilization might have constructed a Dyson sphere, enclosing the star to capture its energy. This concept, proposed by Freeman Dyson, aims to harness a star's energy. Imagine a civilization so advanced that it needs all of its star's energy. A Dyson sphere would gradually obscure the star from view. If N6946 BH1 was such a star, its dimming could signal this colossal project. The star isn't gone, it's just hidden. The structure would re-radiate energy as waste heat, visible in infrared. Section 8, Beyond Known Physics, Whispers of the Truly Unknown. While direct collapse black holes, failed supernovae, and even Dyson spheres offer frameworks for understanding N6946 BH1's disappearance, we must also humbly acknowledge the limits of our current knowledge. The universe has a habit of throwing phenomena at us that don't neatly fit into our existing theories. Could the vanishing star be a signpost pointing towards entirely new physics, or a type of cosmic object or interaction that we haven't even conceived of yet? This is where science meets the frontier of the unknown, a place of both excitement and profound mystery. It's what keeps us looking up. Perhaps there are other, even more exotic ways for a star to end its life, or to be obscured, that our current models of astrophysics don't encompass. Could it involve interactions with dark matter or dark energy in ways we don't understand? Or perhaps some form of ultra-powerful, naturally occurring cosmic entity or phenomenon that can consume or cloak a star? These ideas are of course highly speculative, bordering on science fiction. However, science progresses by encountering anomalies, observations that don't fit the established paradigm. Each anomaly is an invitation to think bigger, to explore new theoretical landscapes. It's important to approach such possibilities with caution. Scientists rightly favor explanations grounded in established physics. But we also must remain open-minded. The history of science is filled with discoveries that overturned previous certainties. Section 9, Cosmic Riddles, the Legacy of a Vanished Star. The sudden disappearance of N6946 BH1 reminds us of the universe's immense mystery and wonder. This event, a star vanishing without a supernova, has shaken the astronomical community. It forces us to reconsider the fates of massive stars and their subtle end-of-life scripts. Such events are rare, or perhaps we're just now noticing them. If direct collapse into black holes is common, it affects our understanding of black holes and gravitational waves. Each silent star death means fewer heavy elements dispersed into the interstellar medium. This influences the formation of new stars and planets. The universe is interconnected, and one star's fate affects its cosmic neighborhood. The search for techno-signatures, evidence of alien technology, is a legitimate scientific pursuit.